Okay, so if you can turn in your books to lesson 5. Lesson 5 is on page 407. Page 407. So we're looking at roots again. So we're continuing on from yesterday, and remember for review from yesterday, when a question is asking for zeros, roots, or x-intercepts, those are all the same thing. And in all of those, what were the steps? First, set somebody to 0. Who did we set to 0? Make a guess. Y equal to 0. So we set y to 0, and then we had to usually factor to find what our x values were. So factor, and then we could solve for find what x equals. And if it was quadratic, there was going to be 2 solutions. So consider the equation that we have here. We have x plus minus 3 and x plus 6 being multiplied together, and that equals 0. And so we're working off the property that a times b equals 0. And so if a times b equals 0, then we know a is equal to 0 or b is equal to 0. So since x minus 3 is a factor of the equation, then what is the root of the equation for x minus 3? So what would x have to be to make that 0? That'd be 3. Same idea, since x plus 6 is a factor of the equation, then what is the root? The root would have to be negative 6, because negative 6 plus 6 would give you 0. Reversing the process, we're going to go backwards today. So if we know the root, let's write the equation. And we're going to make our equations knowing our roots. So reversing the process, if the 3 is a root, then what would be the factor? The x minus 3. How do we get that? Well, if we know x is equal to 3, we want one side to be 0, we'd have to subtract 3 to both sides. And you're left with x minus 3 equals 0. So if negative 6 is the root, then what is the factor? So again, you have x equals negative 6. Solving for 0, we add 6 to both sides, and we get x plus 6 equals 0. And so that would be the factor. So we're going to work backwards today. So if 3 and negative 6 are the roots, then we know the equation would be x plus 3 times x minus 3 times x plus 6 equals 0. And so we did that a little bit last unit. But remember, this doesn't tell us our a value. And so we're going to go later on in our lesson and know, okay, we got the roots, but how do we figure out the a value? And we're going to need a point to do that. Okay, so if you could highlight or circle this the second bullet there. So the second bullet says, if a quadratic equation has roots m and n, then we know in factored form it would be a times x minus n times x minus n equals 0. And we looked at that in our last unit, right? It's very similar. A lot of the same stuff. But all we're doing this unit is we're incorporating our factoring. Okay, so let's write each form in the form of x minus m times x minus n. Note here that there's the a value equals 1. So they're telling us a is equal to 1. Other situations, if we don't know that, we're going to have to solve for a. So if these are my roots, how would we write, if negative 7 and 1 are my roots, how would I write that? So we're going to use this equation, right? And this is why it's the opposite. So if we have x minus 7, it becomes x plus 7 times, and if we have a positive 1 as a root, it becomes x minus 1, and that equals 0. Now they want it in the form x squared plus bx plus c equals 0. So expanded form. So how do you expand a binomial times a binomial? FOIL. So FOILing this out, we start with x times x, given x squared. Then x times negative 1, so the outsides, we have negative x. Now our inside, 7 times x, gives you plus 7x. And our two last terms, 7 and negative 1, is negative 7 equals 0. And And so just collecting like terms. Remember, our like terms are in the middle always when we FOIL. X squared plus 6x, because we have negative 1 plus 7 is positive 6, minus 7 equals 0. So there you go. So let's try another one. X minus 2, or sorry, negative 2 and negative 3 are our roots, so let's write it in factored form. So it becomes x, so if it's a negative 2, becomes positive 2, because negative 2 plus 2 would give you 0. And x plus 3 equals 0, because negative 3 plus 3 would give you 0. So again, in foiling this out, x times x squared, x times positive 3, positive 3x, then the 2 times the x is 2x, and 2 times 3 is 6. Now our last step is collect like terms. So x squared plus 5x plus 6 equals 0. There you go. Okay, let's look at one where it's 0. 0 and 4. So you'd have x minus 0 and x minus 4. Again, they're opposite signs. What is x minus 0? It's just x. So we could just write x times x minus 4. And now the nice thing about this guy, we just have to use distributive law to expand him. X times x is x squared. And x times negative 4 is negative 4x equals 0. Now we're done. So we're just working backwards today. So all the same stuff again. What's going to be different is if we have to solve for a. So that's it for this page. Let's turn over. Consider the equation 2x minus 1 and 3x plus 4. We have seen this quadratic equation can be solved by determining the x-intercept, so the graph, right? And we did that last day. So, or we can look at the roots, right? So second opposite sign, second over first. So 1/2 and negative 4 over 3 would be what x is equal to. Or we can look at our graph and you can use your calculator. So since 2x minus 1 is a factor, then the x-intercept would be positive 1/2. Now you don't have to use the shortcut, which is the opposite sign, second coefficient over the first, or the second over first, or you can go 2x minus 1 and set it to 0, solve for x. So add 1, 2x equals 1, then divide by 2. X equals 1/2. So same idea with 3x plus 4. You can set it equal to 0. So solve for x, subtract 4. So 3x equals negative 4, then divide by 3. X equals negative 4/3. So what's the shortcut? Opposite sign. So minus sign, and then second over first. So the same idea if we work backwards. So if it's 1/2, it might be a little bit harder to figure out the factor. So it's second over first, right? So an opposite sign. So this guy, if we wanted to work backwards, this would have to be 2x minus 1 to give you 1/2. Now, if we know that x equals 1/2, how would you also rearrange this so our equation equals 0? And making it a nice factor like that with no fractions. Well, we'd first times by 2. And we get 2x equals 1. And then subtract 1. 2x minus 1 equals 0. Okay? So the idea of negative 4/3, it's going to be opposite sign. And so the bottom always goes in front. So 3x plus 4. 3x plus 4. Well, how else could you have gotten that? Well, our solution for our 0 was x equals negative 3/4. So you always take care of the fraction first by multiplying both sides by whatever's on the bottom. So in this case, it's 4. So now I have 4x equals negative 3, and then add 3 to both sides because we want to make 0. And negative 3 plus 3 will give you 0. So 4x plus 3 equals 0. Okay? So, yeah, we have 2x minus 1 multiplied by 3x plus 4. So notice how we always use 2x minus 1 instead of x minus 1/2. We always want to avoid fractions because it's not proper to write it in that form. So let's look at an example. In order to express a quadratic equation in factored form, Michaela graphed the corresponding function and determined that the x-intercepts were 3 over 5 and 5. Determine a possible equation for the factored form in general form. So remember, general form is ax squared plus bx plus c. That's really important. Just to review that from last unit. So they give us our m and our n. Our m and our n. And recall that our formula is, when we were making our function back in the day, was a times x minus m times x minus n. Now notice they say determine a possible equation. Why would there be more than one possible equation? They tell us the roots. The roots aren't going to change, but what could change in this equation? And that is our a value, right? They didn't tell us our a value. So we can pick an a value. We could also just use 1. Let's just use a value as 1, because we can do whatever we like. So we're going to use a as 1 because that would be the simplest. Okay, so let's put this equation, and we want it in factored form. And how would it be made to determine so in factored form. So set it equal to 0. So we'd have, now our m was 3 over 5. So what would the equation be? One way we can make it is x was equal to 3 over 5. So what would we do first? Multiply both sides by 5. Get rid of the fraction. So 5x equals 3. We want this side, second side, to be 0, so we're going to subtract 3. So 5x minus 3 equals 0. And would that give us a 0, positive 3 over 5? Yes. Or we can use our shortcut. Our shortcut, the bottom number goes in front, and it's going to be opposite sign. So this was a positive, we're going to use minus. And then the top number goes in the back. 5x minus 3 times 5 just becomes x minus 5 equals 0. It's a little bit easier the second one when it's just not a fraction. Now it wants it in general form, so what are we going to have to do? FOIL. Okay, so 5x times x is 5x squared. Those are first. Now our outside. Our outsides are 5x times negative 5, negative 25x. Now our insides, negative 3 times x is negative 3x. And our two last numbers, negative 3 times negative 5. Remember, 2 negatives. It's a positive 15. Okay, so now we're just going to collect like terms. Remember, our middles are our like terms. 5x squared minus 28x plus 15 equals 0. So there's the factored form, and there's the general form. So I wanted in both. Okay, so next page. Using zeros to determine a quadratic equation. We can use the same process to write a quadratic equation in factored form. We're given the zeros of a corresponding function. So in order to express a quadratic equation in factored form, Chris determined the zeros of the corresponding function to be negative 3 over 4 and 2. Determine a possible quadratic equation in the form ax squared plus bx plus c, so general form. And it says a, b, and c are integers, so they should have no fractions. Okay. So our first step is to write our equation. We need to make our zeros. So we have our m and our n. So this becomes, if we want it as a factor, remember the bottom number goes in front, 4x, opposite sign, and then the top, 4x plus 3. Or what could you do? We have when x equals negative 3/4. First step, get rid of the fraction, so times by 4. So 4x equals negative 3, and then add 3 to both sides. And that gives you the same thing. 4x plus 3 equals 0. Okay, the next one, x plus 2 becomes x minus 2 equals 0. And it wants it in general form, so let's How do we expand it? We FOIL. So again, first, 4x times x, 4x squared. Outsides, 4x times -2, -8x. 3 times x plus 3x. And positive 3 times -2 is -6. Okay, and now we just collect like terms, which again are in our middle. So we have 4x squared minus 5x minus 6 equals 0. Write a different equation in B, it says, which satisfies the question of the conditions of the beginning. So what could you change? Remember our original formula for factored form was a x minus m, x minus n. So we can change our a value. So it'd still give us the exact same 0. So say if we made our a value 2. So this equation, 2 times 4x plus 3 times x minus 2 equals 0. Right? That would still give us this exact same 0. So if we expanded that out, we already know what this is expanded. If we expanded this part right here already, it was 4x squared minus 5x minus 6. So if we just double the whole equation, it'd still give us the exact same zeros. 8x squared minus 10x minus 12 equals 0. Okay, so carrying on. Using zeros, roots, and x-intercepts to determine a quadratic equation. Nathan is determining the equation of a function represented by the graph shown in the diagram. He recognizes that the x-intercept is -2 and 6 and concludes the function is x plus 2 times x minus 6. Does the point 3, 30 lie on the graph of Nathan's function? So we can check that by plugging in our x equals 3 and see if it comes out as 30. So let's try. So if we plug in f of 3, x equals to 3. 3 plus 2 times 3 minus 6. 3 plus 2 is 5. 3 minus 6 is -3. That gives me -15, which is not positive 30. So he made a mistake in making the equation, right? No, 330 is not on Nathan's equation. So what was wrong with Nathan's equation? He was right setting up his x-intercepts, but where did he make a mistake? So he forgot about who? He forgot about the a value. He missed the a value. Right? So it should have actually been f of x equals a times x plus 2 times x minus 6. And we could figure out the a value because we do know another point other than our x-intercept. So if we know our y-intercept or any other point other than our zeros, we can find our a. So show how Nathan can determine the a. Well, we have a point, so we know an x and a y. We can plug that in. We did this last unit, right? So we can plug in 3, 30 to get our point. So we get 30 is our y equals 8 times, and x is 3. 3 plus 2 times 3 minus 6. We actually already know what 3 plus 2 times 3 minus 6 equals. We did it above. It was -15. And so I get 30 equals -15a. So last step to get a is divide by -15. So a is -2. So his equation should actually have been f of x equals -2, which makes sense. Our graph opens down, so it should have a negative a value. X plus 2 times x minus 3, or x minus 6. There's our answer. All right, 2 more questions, and then we're done this lesson. Turning over to the next page. All right, so it says a quadratic function in the form f of x, a times x squared plus bx plus c has zeros 4 and 8. If f of 1 equals negative 9, determine the function. So here, whenever they give you zeros, we're always kind of following the same steps. Our first step is we're going to write in factored form. So write equation in factored form. In factored form. And so that's using the equation y equals a times x minus m times x minus n. Our second step is we're going to sub in an x comma a y, a point. Sub in point x, y, solve for a. And then rewrite the equation with a. You might have to expand it if it wants it in general form, but that's what you need to do. Okay, so let's follow those steps. So we're going to write the equation in factored form first. So step 1 is we're using the equation a times x minus m times x minus n for given our zeros. So we don't know our a value, so y equals a times. Our first zero is 4, so that becomes x minus 4, because 4 minus 4 would give you a 0. The next one that give you 0 is negative 8, so x plus 8, because negative 8 plus 8 would give you 0. So now that we have our equation in factored form, we still need to find our a value. So how do we solve for our a value? Well, the second step is to plug in our point. So when something is written as f of 1 equals negative 9, it's saying that, right up above here, saying that your x is 1 and your y is negative 9. So let's plug in y is negative 9 and x as 1. So now we have negative 9 is equal to a times 1 minus 4 times 1 plus 8. So we can simplify inside our brackets. 1 minus 4 is negative 3. 1 plus 8 is 9. And so we have negative 9 is equal to negative 3 times 9 is negative 27, so negative 27a. And our last step is to divide both sides by negative 27. We should always answer it in fraction form. We should reduce this. So remember, 2 negatives equal positive, so our a value is equal to a positive, and 9 over 27, well, 9 will go into 27 3 times, so it's positive 1/3. Now we have our a value. The third step is rewrite the equation with a. So we have y equals, a is now a third, x minus 4 times x plus 8. Now the question is, are we done? So always double check the form they want the equation in. We want the equation in general form, so expanded form. So when we have this, our first step would be to FOIL out. We would bring in our a last. So we're going to FOIL our binomials that are being multiplied together. So leave the a in front. We'll bring that guy in last. So let's FOIL again. First times first. X times x is x squared. X times positive 8 is 8x. Negative 4 times x is minus 4x. And 4 times 8, or negative 4 times 8, is negative 32. So let's collect like terms. So y equals 1/3 times x squared plus 4x minus 32. So notice how we had like terms. And now we just need to distribute the 1/3. Okay, in. So if you have a calculator, it might help you. We're going to leave everything as in fraction form. So 1/3 times x squared is just 1/3 x squared. But what about 1/3 times 4? Well, if you're not very strong with your fractions, you can use your calculator. So we go 1/3 times 4, and then math, enter, enter. And it's 4/3, right? With fractions, we go straight across. 1 times 4 is 4, and then 3 times 1, because it's 4 over 1. So 4/3 x plus 4/3 x And then a third times negative 32. So again, 1/3 times negative 32 gives me a decimal. So I'm going to go math, enter, enter. It's negative 32 over 3. It doesn't reduce. So negative 32 over 3. And that's our final answer. There you go. Okay, so those are the 3 steps. So that would be a really good written response question. So one more question and then you're all done. Consider the function 6x squared plus 8x minus 14. Show how to write the function in factored form using the graph of the function. Okay, so we're going to actually use our graph to help us. So let's grab our graphing calculators and help ourselves with by graphing it. So we're going to plug in our function. Our function was 6x squared. 6x squared plus 8x minus 14. Go ahead and push graph. Remember, if your windows are weird, you can push zoom 6. Now, maybe we want to zoom out a little bit. We want to go down, right? We need to go down a little bit. So if you go to the window button, let's go down to our y scale. And instead of going to -10, maybe let's make that -20. And then push graph. So that gives you a little bit of a better picture of what's going on. So let's roughly sketch that. So roughly sketching something like that. That's a very rough sketch. Okay, so what do we need to make the equation? We need first and foremost, we need our zeros, right? We need these guys, our zeros. So it says show how to write the function in factored form using the graph of the function. So first, we're going to find the x-intercepts. Okay, so let's first find the intercept. So let's grab our graphing calculator. So how do we do that on our graphing calculator? Push second, trace, and we want to go our zeros, number 2. So number 2. So we want left bound. So on this side, it's going to be the left side would be above it, and right side would be below. So you're saying, yeah, my zero's in between those two values. And how do we change it into a fraction if we get a decimal? Remember, your calculator automatically stores it. If you quit, you go x, math, enter, enter. -7 over 3 is one of them. -7 over 3. And the other one, so we have to go through the same stuff again. Go to graph, second, trace, number 2 for 0. Now left bound, this side will be the left. Below the curve is on the left. We're saying, I want it between these two values. And then the right was above, make a guess. And it's exactly 1. So -7/3 and 1. Okay? So we know the zeros, but that doesn't tell us our a value, right? And so how do we get our a value? Well, we know we need another point on the graph. So if we wrote this in factored form right now, we'd have y equals a times, now we don't write it as x plus 7/3. Instead, we're going to write it as, remember the bottom, 3x, opposite sign, plus 7. So that would give you the zero of -7/3, and then times x minus 1. So now we have that, we still need our a value. To get your a value, well, what were the steps above? It said, write the equation in factored form, which we did, and then sub in a point. So we need a point. Well, we could figure out a point quite easily. The easiest point to always use is our y-intercept. And there's 2 ways we can get that. We know our y-intercept, we can go trace 0, enter. It's -14. Or looking at our equation, if we set to x equal to 0, this was 0 and this was 0, then here's my y-intercept of -14. So we're going to sub in y-intercept, which is 0, -14. And we're going to solve for a. That was the second step. So let's plug that in. -14 is equal to a times 3 times 0 plus 7 times 0 minus 1. So -14 equals a times 3 times 0 is 0. 0 plus 7 is 7. 0 minus 1 is -1. So have negative 14 is equal to a times 7 times negative 1 is negative 7. And then last we divide both sides by negative 7. So a is 2. So now we know our equation, right? Our equation is y is equal, in factored form, 2 times 3x plus 7 times x minus 1. There you go. There's our equation in factored form. Okay, so that's one way you can do it. You can use your graphing calculator. You actually might find factoring it a lot easier. So if our equation is 6x squared plus 8x minus 14, what's the first question we ask ourselves when we want to factor it? Is there a greatest common factor? And the cool thing is that's going to be our a value. So is there a greatest common factor? Yes, we can divide everything by 2. So if we factor out 2, okay, so let's factor it out. So 6x squared divided by 2, 3x squared. 8x divided by 2, 4x. And negative 14 divided by 2, minus 7. So now we still have to ask ourselves, okay, now that we've pulled out the greatest common factor, is it simple or complex? Well, because of the number in front of the x squared, this guy is complex. So if it's complex, we want two numbers that multiply to what? First times last. 3 times negative 7, or negative 21, and adds to 4. And adds to 4. So if it's multiplying to a negative, what do we know about both numbers? One is positive, one is negative. So negative 21, you could have negative 1 and positive 21, 1 and negative 21. We could do negative 3 and positive 7, or 3 and negative 7. And so which one of these adds to positive 4? Well, it has to be negative 3 and 7. We're going to add to a positive, the larger number is positive. So negative 3 and 7. Now, if it's complex, we can't just go putting these in the brackets, right? We're breaking up our middle term. So we're going to write instead, leave the 2 on the outside, 3x squared. So instead of 4x, we're going to split that up to minus 3x plus 7x. The order in which you write those does not matter. Okay, so now we have 4 terms. What do? Factor by grouping, right? We're decomposition. So we've broken it up, and now we're going to use factor by grouping. So 2, the first 2, what can you factor out of 3x squared and 3x? What can we divide by both of them? 3 and x. And so what we're left with, if we divide both of these by 3x, the first one, 3x squared divided by 3x is x. And negative 3x divided by 3x is just minus 1. Anything divided by itself is 1. And there's a minus sign in front, so negative 1. The next two, what can we divide 7x and negative 7 by? We can both divide them by 7. So we're going to factor 7 out. So divide each by 7. We're left with x minus 1. Okay, so one more step. We still have this 2 out in front. And we have an x minus 1 in common, so we're going to factor that out. We're left with 3x minus 7. So you might actually find this way a lot easier. Now it's in factored form. You can see your a value and you can see your zeros. There you go. Okay, so your homework for this assignment is all numbers 1 to 11.